during the break, please go ahead and share with us. Go ahead and drop it down in the comment section. If you're having any difficulty, likewise, go ahead and drop it in the comment section, because I love to see your progress. I'd love to see your progress. Hi, Juliana, what's up? How are you? You're welcome. David, what's up? Oscar, what's up? You're welcome. Paul, I'm super excited to have you guys back again. Yeah, I'm super excited to have you guys back here. Michelle, Antonio, you're welcome. Oscar, yeah, I'm doing great. I'm super excited to have you guys. Please, if you've done something amazing during the short break, please go ahead and drop it. If you've done an amazing project, I would love to see it. Maybe after this session, I'd love to see. If you are having any difficulty, please, I would love to see your difficulties so that we can set aside a time to address them. Please smash the comment section. I want to feel the energy, please. Yeah, please, if you've seems like nobody has done anything amazing. Does that mean that none of you has done anything amazing during the break? Please, if you've done something, maybe be it analysis, be it visualization, anything, maybe a mini project, please go ahead and drop it in the comment section. What have you done during this break? Did you practice? Did you sleep? Just go ahead and drop something amazing in the comment section. Yo, Jackson, what's up? You're welcome. Meanwhile, let me just go ahead and share my screen with you guys. I think I'm just going to share my entire screen to make things easy. Please, Justice, please do verify if my screen is visible to you guys.
Yeah, it's visible.
All right. Okay, Oscar said I was able to make my notes from class 1 to 9. Wow, that's amazing. If it's in a PDF format, please, I would love to see. I would love to see. Yeah, please, if you prefer to speak, you can unmute yourself and speak. Yeah, please. I want it to be very interactive. Please do not shy away. Just go ahead and unmute yourself and speak, please. If you're having any difficulties, do not hesitate to drop it. Please talk to us. We're here to listen.
Good evening, all.
Good evening. Please, your name and where you're joining from, please.
My name is Juliana Mbemere. I'm from Lagos.
Wow, that's amazing.
I practice Matplotlib and Seaborn.
Wow, that's amazing. Matplotlib. How many charts?
Yes.
So were you able to visual
I practice all of them.
Wow, that's amazing. That's amazing. I would love to, please, maybe after this session, I would love to see.
I visualize all of them.
Do you have it in a notebook file or something like that?
Yes, I have it in my my file.
Please, if it's in a Jupyter notebook, I would love to see it maybe tomorrow or something like that. Maybe after this session.
I have it in Jupyter notebook.
Please, I would love to see it because I want to hold you guys accountable, honestly speaking. Okay, Engineer Godwin, you're welcome. Wow, that's amazing. That's amazing. Engineer Godwin. That's amazing. That's amazing. Juliana, please do not hesitate to share your notebook with us. Maybe after this session or tomorrow. Just go ahead and drop it in the WhatsApp group, and then I can be able to access it from there.
All right.
So please, without any further ado, I want us to go through what we did so far, because we've done a lot. I lost you guys for a minute. I don't know, maybe if the problem is with Zoom or me, I don't know. Hello, please do verify if I'm audible.
You're audible, sir.
All right. Please do verify if my screen is visible.
Yes.
All right. So let's do a recap before we continue, please. And during our week one, we've covered overview of data analysis, and we talked about types of data and data set organizations. In our week two, we covered the basic of Excel for data analysis, where we covered some built-in Excel functions like the sum, the average, and the count, and so much more. And then we also covered data formatting and data cleaning. And we've already covered intermediate Excel skill, where we learned how to VLOOKUP, to HLOOKUP, pivot tables, and the rest. And then we also learned how to visualize data in Excel. And we've done some advanced stuff as well, where we covered some conditional operators in Excel and some data validation. And we also covered some scenario analysis using goal-seek and what-if analysis, right? And then we've done some introductory aspect of Python, where we covered some basic programming concepts and built-in Python data structures. We also learned how to manipulate data using pandas. And after that, we covered some intermediate data analysis skills. We handle some missing values and outliers in Excel. And we also visualize some data using Matplotlib and Seaborn. And during our week 7, we covered some advanced pandas where we covered grouping, margin, and so much more. And we also covered some. Today, I believe today we're going to be starting with this week 8. We were supposed to cover this last week, but because of the break, we couldn't cover this. Today, we're going to be talking about some machine learning. I'm going to be introducing you guys to machine learning, and then maybe to in our next class, we're going to be building some machine learning models. So please, okay, I'm reading the comment section now. Please, it doesn't have a name. It's I was able to do my practicals, most especially in Jupyter Notebook, where I visualize everything he taught us, and I have as well developed my notes. I still went back to Excel and started my practice intermediate level. Yeah, please, I do encourage everybody to go back to Excel. Please, if you're facing any difficulty in Excel, I myself, sometimes I do go back to Excel because Excel is so a bit complex. You forget the formulas easily, but practice makes permanent. Please, I do encourage you guys to go back to Excel and practice more, please. So without any further, let me just go ahead and share my slide with you guys. Please do verify if my PowerPoint presentation is visible to you guys.
Yes, it is.
All right. Today I'm going to be introducing you guys. Today we're going to be doing some theory aspect of machine learning, and then maybe in our next class we are going to be building some machine learning models. So this is I've been super excited to begin this part of the hackathon with you guys because I do love machine learning. Machine learning is so amazing. It's so ubiquitous these days. So why learn machine learning? Let's take a look at some key concepts before we move further. It has been projected that AI could potentially augment Africa's GDP by $1.9 trillion by 2030. And the demand for AI and machine learning specialists will grow by 40%. See, if you're planning to be a machine learning engineer or a data analyst, it doesn't matter because data analysts do not only analyze data and give feedback and generate reports, they also predict, they also make predictions, right? They also make some predictions. So as a data analyst, you're going to be doing a lot of machine learning stuff because these days everything is about AI and machine learning. We all know that, right? So the demand for AI and machine learning specialists will grow by 40% from 2023 to 2027. So as you can see, we're in 2025. So 2 years from now, the demand is going to be grow by 40%. And the average machine learning engineer salary is about, on average, is about $133,000 per year. That's in millions. Just do the calculation. And 8% of machine learning engineers require Python programming because you're going to be doing 99% of machine learning with Python. And the most required Python library for machine learning are TensorFlow, Keras, and Scikit-learn. We're going to be covering TensorFlow and Scikit-learn in our next class. Yeah, we're going to be doing TensorFlow and Scikit-learn. And 8% of machine learning jobs are in the IT services and consulting sector. IT services and consulting sector. And 6% of machine learning engineering jobs are for entry-level positions. So a lot of students ask me, sir, please, as a beginner, how do I have any chance? What are the odds? What are the probabilities that I might get an entry-level job, an entry-level position. So 6% of machine learning jobs are for entry-level positions. 6% is a big number, right? So if you want to read more about this analysis, these numbers actually, I'm not the one that came up with these numbers. They're actually an analysis and a forecast done, and it's available on 365datascience.com /career advice /machine learning engineering job, right? So this is the source of this analysis. So it's a solid analysis. So I'm gonna be talking about the machine learning journey with you guys.
Yeah, MK, we can hear you again. Please, can you check your audio?
I believe I'm audible now, right?
Yes, sir.
All right. Please, whenever there's an issue with the mic, please do not hesitate to call my attention, please. I'm coming. Just give me a second. I'm fixing some issues, please. Settings. Yeah, I'm setting something so that whenever the mic is off, it's going to notify me. Yeah, beautiful. So let's continue, please. Sorry for that. SQL basically means structured query language, right? So for the purpose of absolute beginners, I know we have many absolute beginners here. We've already covered in our Excel class that Excel is only capable of storing maybe 1.6 or 1.7, 1 point something million rows, right? So as your data becomes larger and larger and larger, it's going to be beyond the power of Excel, right? So that is where SQL database comes into play, right? So you need to learn as a data analyst and as a machine learning engineer, or as a data analyst wanting to learn, wanting to incorporate machine learning into their skills, you have to learn SQL basics, right? So the next thing is level 2 programming. After you've done with your level 1 programming, whereby you can confidently write some simple programming concepts in Python, you need to learn level 2 programming. Level 1 is all about procedural, and level 2 is all about classes and everything. This is where you learn functions. Sorry, this is where you learn object-oriented programming, where you start working with classes. Though level 1 is enough, because honestly speaking, almost all the machine learning almost all the heavy lifting is done for you already. Like many years ago, like 6 to 7 years ago, you have to learn level 2 programming. But now I believe even level 1 programming is okay, because most of the heavy lifting is already done by all these machine learning libraries like scikit-learn and TensorFlow. All the mathematics, all the calculation and everything is already done for you guys. So you can just use it out of the box. But level 2 programming is as you continue your data analysis and machine learning journey, you're definitely going to reach level 2 programming. And then maybe after that, NumPy, Pandas, and Matplotlib. We've already done that. We've already done Pandas and Matplotlib, right? I don't have to talk much about this because you guys already know Pandas and you guys already know Matplotlib, right? So we don't have to waste time on that. And then after you're proficient with Pandas and Matplotlib, the next thing to learn is mathematics and statistics. Though this is not mandatory, but I recommend you guys to learn the basic of mathematics and statistics. You can go to Khan Academy and learn the basics of mathematics needed for machine learning. Though all the mathematics, all the maths needed to build a machine learning model is already done. You don't have to reinvent the wheel, right? It's already done. Though it's recommended for you guys to know what's happening under the hood. It's recommended for you guys to know what you're doing, right? So you have to know the basic of statistics, like probabilities and everything, right? So after you're proficient with, after you're done with the basic mathematics, the next thing you need to learn is the machine learning libraries, which we're going to be doing in our next class, right? So the library we're going to be using, it's scikit-learn and TensorFlow, right? And then maybe if you want to go deep into the rabbit hole, you can go into deep learning, right? Though for beginners, I do not recommend this for beginners, but as you become intermediate, you might want to learn deep learning, and TensorFlow is a very nice and amazing library to do that. And ML Ops, this is a bit advanced. When you become advanced and you want to bundle all your operations and everything, this is where you learn ML Ops. But this is not mandatory. Honestly speaking, this is not mandatory. So the other skills needed these are the soft skills that are needed to become a proficient machine learning practitioner. So the first thing that I'm going to be talking about is Fast API. So let me not make things complex for you guys. Fast API is basically a framework for building APIs quickly, right? For example, let's say you want to fetch data on the internet and perform analysis on them. So most of these data that you're looking for, they can be accessed through an API. An API basically means an application programming interface. So that is the reason why learning API is so crucial to be an intermediate to advanced data analyst and machine learning engineer, right? Fast API is simple. You can learn Fast API in like maybe 3 days, something like that. Maybe if you're a slow learner, it's going to take like maybe a week or something like that. The next thing I want to talk about is GitHub, right? GitHub. So GitHub is just a collaboration tool, right? It's just a collaboration tool. So for example, you have your Jupyter notebook, right? And then maybe you want to track your changes over time, or you want to maybe share it with maybe you're working with a team and you want to be working on a single file, right? Maybe your team are all around the world. Maybe you have a team, maybe in Canada, in USA, right? And you guys are working on a project. So GitHub helps you guys to collaborate, right? and automate everything. And the next thing that I want to talk about is MongoDB, right? MongoDB. So initially I talked about SQL, right? Because as your data becomes so big, as your tables become very large, you are going to be needing, you're going to be going into SQL, right? But we also have a MongoDB, right? Which is a NoSQL database for storing like a JSON file. It has a very flexible schema, and it's like a Python dictionary. It's just like a Python dictionary. Let me not complicate things for you guys. So it's another option of database. If you don't want to work with the SQL, it's just another option, right? And Jupyter Notebook, I don't have to talk much about this Jupyter Notebook. You guys are already familiar with Jupyter Notebook already because we've been using Jupyter Notebook so far. And this Docker as well. Please, most of the beginners say, oh my goodness, this is so much to learn. This is so much to learn. This is so much. Don't worry, I'm just familiarizing you guys with this concept, right? I don't want a situation whereby my students will see Docker and they have no idea about it, right? So now if you see Fast API, you can easily brag about it. That, Fast API is for fetching data online. GitHub is for collaboration. MongoDB is another database. You already know Jupyter Notebook, right? I don't want a situation whereby you see Docker and you're like, oh my goodness, what's Docker, right? As you progress in your career, you're going to be learning all these things, right? So do not be overwhelmed, please. So Docker is a containerization tool, right? It packages all your apps and all their dependencies together in a one place. As simple as that. It packages everything. It's a container. For example, now just let me use this analogy. It's like a container for putting everything, for packaging everything in one place. Packaging everything, all your dependencies and everything in one place, right? Like your Python libraries, your Jupyter Notebook setups and settings, it bundles everything into one place so that whenever you, maybe whenever you share a notebook with someone, right? For example, there are some certain libraries that are installed into the notebook. So whenever you bundle them in a Docker container, the person that you share the data with can just easily open, install, and use it, right? As simple as that. And then we also have Hadoop. Hadoop is not that complex. Hadoop is just a larger database, right? It's a very large database for storing billions and billions of data, right? As simple as that. It's just another large database. We have MongoDB, we have SQL, and we also have Hadoop, right? So Hadoop is just the elephant in the room, right? As simple as that. It stores billions and billions of rows of data, as simple as that. And then we also have CI/CD. As you become a bit advanced in your career, you're going to come across this CI/CD, which is just continuous integration and continuous development. It's just a tool that we use to automate validation of data pipelines. Like whenever you want to automate your testing, let's say you've written some code and then you want to test it and then you want to maybe automate the process of testing it, right? So this is where CI/CD comes into play. For example, whenever you want to push an update to your to your apps or to your database or something like that, CI/CD automates the process, right? It automates the process. So you can also use GitHub to do that. You can also use tools like GitHub Actions or Jenkins or GitLab to automate all your processes, but we also have CI/CD. So I just want you guys to familiarize yourself with these technologies that are readily available for you guys. Please do not be overwhelmed. All for now is to maybe as you become intermediate, I recommend you guys to learn this Fast API. And what again, you're already familiar with this Jupyter Notebook, and maybe GitHub, please, because GitHub is where you save all your notebooks. 20 years from now, they're going to be available for you guys. It doesn't matter. Even though you lose your laptop or whatever, your files are going to be available on GitHub for you. So I recommend you guys to start learning Fast API, maybe GitHub, and yeah, you're already familiar with Jupyter Notebook, right? So with that out of the way, let's jump right into the machine learning concept. So let me clear this out of the way. So we have we have 3 layers of machine learning, right? We have we have artificial intelligence, which is AI. A lot of people mistake machine learning and AI, right? Because most people don't know the difference between machine learning and AI. You see people calling machine learning AI, and you see people calling AI machine learning or machine learning deep learning, right? It's wrong, actually. Honestly speaking, it's wrong, please. It's wrong. Let me use this analogy. Artificial intelligence is the parent, right? It's the parent. And then machine learning, let's consider machine learning as maybe the son or the daughter, and then deep learning as the child or as the granddaughter. Artificial intelligence is the broader term, and then machine learning is the subset of artificial intelligence. It's like a branch of artificial intelligence. And then deep learning is the subset. Machine learning evolved and became deep learning, right? As simple as that. As simple as that. If you like, we can go and blow some English there. AI is just a technique which enables machines to mimic human behavior, right? They are just mimicking human thinking, human brain, how the human brain works, right? And then machine learning is the subset of AI which uses statistical model to enable machines to improve with experience. That's machine learning. AI is the ability of a computer to mimic human brain, and then machine learning, right? It allows the AI, which is the brain, to learn from data using some statistical models, as simple as that. And then deep learning is the subset of machine learning, right? Which make the computation of multi-layer neuron, right? And perceptrons feasible, as simple as that. It uses neural networks. And then machine learning uses some statistical models, and then it evolved, and then we developed the neural networks, as simple as that. Please just know the difference. If you want to use some analogy, I always tell my students that AI is the broader term, is the father, machine learning maybe is the son, and then deep learning is the grandson. Simple as that. So the next thing I want to talk about is the types of machine learning. We have many types of machine learning, right? We have many types of machine learning. Like we have supervised, we have unsupervised learning, we have reinforcement learning, we have under supervised, we have classification and clustering. Sorry, classification and regression. Under supervised, we have clustering, and then under reinforcement learning is actually used in robotics. We're not going to be covering reinforcement learning because we are not dealing with robotics. Maybe, I don't know, maybe IGTA is gonna organize maybe a hackathon on robotics in the future. I don't know, because right now I'm doing a lot of research on this reinforcement learning. And what we're going to be talking about is unsupervised and supervised, right? Because we're doing data analysis here. So let's talk about supervised learning. Is actually very simple. It's very, very simple. Supervised learning is when you give a computer a labeled data, right? When you give a computer a labeled data, right? And then you train it, and then later on, you show it the data without the label, and it's going to predict. I don't know, maybe if you get that, please. I don't know, maybe if you get that. It's actually very simple. You just tell the computer that, hey, this is a mango, this is a carrot, right? I don't know, maybe this is a bell pepper, right? And then you tell it the names. It's like you training a child, right? Supervised learning, you give it the data and then you tell it the name. Hey, computer, look at this, it's a tomato, right? Look at this, it's a carrot. Look at this, it's a pepper, right? And then the model is going to train based on that. And then next time, if you show it a carrot, right? If you show it a carrot and then ask it to tell you the name, hey, what is this? The model is going to tell you that this is a carrot. And then same thing goes with bell pepper, and then same thing goes with tomato. It's like showing a child maybe some items with their name, and then maybe as the child develops, And then maybe if you show them this item and ask them, hey, what is this? And then they're going to tell you that, hey, yeah, this is a carrot, this is a bell pepper, and this is a tomato. So in supervised learning, we give the algorithm the data and the label. As simple as that. Please take note of this, more especially the beginners. The data and the label in supervised learning. Supervised, that's where the term supervised comes in place. Supervised learning. You're telling the computer the data and the label, right? And then next we have semi-supervised. Though we are not going to be doing this, we also have semi-supervised learning, right? In semi-supervised learning, you give the computer, please, this data could be anything, right? We're just using some fruits to make this learning fun and interactive. Like this could be student score, right? Or student performance versus their average score. This could be anything. Maybe this is a student performance, and then maybe this is an average score, right? And then you let the model train. And then next time, if you show it maybe the score, the performance of a student and then you ask it to predict based on this, based on the past performance of these students, what do you think would be the outcome of this student in the future? And then it's going to predict that for you. So this could be anything, please. So in semi-supervised, we give large amount of unlabeled data to the AI, right? And then we give some label and some unlabeled, please. That's semi-supervised learning, right? Semi-supervised learning. For example, if you take a look at this illustration, we're giving large amount of unlabeled data, right? In this data set, we're not explicitly telling the AI, sorry, the algorithm, that this is an apple or this is a pineapple, right? We're just giving it a bunch of unlabeled data and then some small amount of labeled data. That's why it's called a semi-supervised. The data set we're giving the model are not labeled. They are partially labeled. Like 70% of the data are labeled, sorry, are unlabeled, and then maybe 20% of the data are labeled. That's why it's called a semi-supervised, right? And then next time, if you give it a data without the label to predict, it is going to predict. As simple as that. The only difference between supervised and semi-supervised and supervised is in supervised learning, we tell the model that, hey, this is a mango. We show it a mango and then tell it that, hey, this is a mango. And then in semi-supervised, we show it like maybe 20 varieties of mangoes without their names. And then maybe we show some small amount of mangoes, like 2 to 3, and then with the labels, right? And then we allow the model to train. After the training, then we give you a test data to predict, and then it's going to predict, right? That is the semi-supervised line. But we're not going to be doing semi-supervised. We're going to be doing supervised and unsupervised learning, right? So we also have unsupervised, right? Unsupervised. Please, I don't know, maybe if you guys recognize the pattern here. I don't know if you recognize the pattern. In supervised, there's label. We show the model an object, and then we tell it the name, right? In unsupervised, so the supervision is the label though. We're telling the AI the label, right? So in unsupervised, we're just showing it these items without any name or anything like that, right? And then we're allowing the algorithm or the statistical model to train based on these features, right? So it will take a look at this apple. Okay, it will recognize that, okay, it has a leaf, right? It is red. It has a, maybe the shape is like a heart, this and that. It's all going to recognize all these patterns on this apple. Same goes with the banana. Same goes to the orange, and then the watermelon, and then the lemon, right? It recognizes all the patterns on these objects, and it's going to save them, right? After that, next time, if you show it an apple, right, it's going to predict, right? It's going to, for example, if you give it this maybe a pineapple, an apple, or a bunch of items that are uncategorized, right? It's going to categorize them. It's going to cluster them, right? As you can see, we're not predicting the names, we're just clustering them, right? We're just clustering them. Don't worry, we're going to be covering K-means clustered. Please pay attention, right? We just gave it a bunch of fruits, and then you see the the model has successfully grouped these fruits into their categories. Apple, we have apple, we have watermelon, and then we have you see lemon and then orange. They are of the same category, right? So this is how they are grouped, as simple as that. So you can use unsupervised learning to group. Maybe, for example, let me add, maybe try to explain this in a data analysis concept. For example, you want to group some students based on their performances, right? Maybe you want to group them, right? Maybe you want to group them into maybe successful and unsuccessful, right? Maybe you want to group all these students. Then you feed their scores and you feed their scores into the model. And then if you give it a bunch of scores, it's going to categorize them, right? It's going to categorize them. As simple as, don't worry, we're going to be covering, we're going to be programming some example in our next class, right? So, and then we also have reinforcement learning. Though we are not going to be, we're not going to be doing this, but as a data analyst, you have to familiarize yourself with this as well. So in reinforcement learning is when we give an agent, it's mostly used in games. Honestly, it's mostly used in games, right? Or in robotics. You give the model an input raw data, and then you put it in an environment, right? This is a bit complex, right? I don't know, maybe if you guys will be able to understand this well. You put an agent in an environment, right? You're not going to be giving it any label. So you allow, whenever the agent does something right, let me use game as an analogy, for example. Maybe you put a robot in a room, right? And then maybe you want the robot to perform some certain actions, but you don't tell it the action to perform. You don't want the robot to perform. You don't want to tell you're not telling the robot explicitly the actions to perform, right? So whenever the robot does something, there's a reward. There's a reward for that. So this is how the robot knows that, okay, I did a certain thing and then I got a reward for it. So that means I should keep doing this, right? I should keep doing this. And we have a selection algorithm. These are the algorithms that I use to help the robot make decisions. And then we also have the state, which allows the robot to know the current state that it's in, right? We also have a best action, right? So whenever the robot does something good, there is a reward for it, right? That is why we gave it this bunch of data, and then it was able to filter and sort them and then categorize them. As you can see, this is the output. This is the output. So I don't know, maybe you guys understood this. It's just putting an AI, if, for example, if you put an AI agent in a room, right? And then you want it to perform some certain tasks, you don't explicitly tell it the task to perform. You just give it a reward whenever it tries to perform the task well, right? Whenever it attempts, right? Whenever it even attempts to do what you want, you give it a reward. That is how the agent knows that, okay, I should be doing this more because I got a reward, right? For example, whenever it does something, maybe you give it a little reward, and then as it continues to do the tasks, you start giving it maybe more reward. This is how it knows that, okay, this is what I gotta do to get more reward. That is how it's a reinforcement learning model is trained. So we also have applications of machine learning. We have machine learning in manufacturing. We have machine learning in retail. We also have machine learning in healthcare science. So regardless of your discipline or whatever that you want to do in your life, there is machine learning everywhere, right? In the energy sector, right? In feedstock utilities, in the hospitals, in finance, in the retail, right? Maybe healthcare and life sciences, manufacturing, machine learning is everywhere. So applications of machine learning is literally everywhere. So this is an example of reinforcement learning. For example, I put this animation just to further explain the concept of reinforcement learning. As you can see on the right side of the screen, this is Google's DeepMind learning how to do a backflip, right? So at first it was attempting to jump and perform a backflip, but it was so difficult. So it's getting a little reward. That is how it knew that, okay, I gotta jump. So now it's jumping, it's getting more reward, and now it's successfully doing a backflip, right? So this is a typical example of reinforcement learning, right? And then we also have Google DeepMind that is learning how to, it taught itself how to walk. So this is another application of reinforcement learning. As you can see, this is a DeepMind, which is another part of Google, right? That are involved in all these machine learning models and everything. So they're just teaching a model how to walk. And this is a typical example of reinforcement learning, right? So we've come to the end of this first session. In our next session, we are going to be covering doing some hands-on project where you see all these things that we've covered in real time. So let me just go to my whiteboard and explain some little concepts for you guys. Let me just go to my whiteboard and clarify some little things for you guys. So I don't know, maybe if you guys are having the same issues, but a lot of my students, let me clear this thing. A lot of my students ask me the difference between machine learning and normal programming, right? For example, let me just clear this for you guys for the sake of absolute beginners. In normal programming, for example, you have an input, right? For example, you have an input like this, right? You have an input like this, and then you have some certain rules. You have some certain rules, right? This input could be data, right? Some data, and this data could be some rows and columns, just like in Pandas and Excel, right? And then maybe you have some rules here, right? You have some rules. You're calculating the mean, right? You're calculating the median, right? You're doing some outlier detection, right? You have some rules here. Maybe you have some certain rules that you explicitly programmed, right, to apply on this data, on this input. And then after that, you have your output, which is the result, right? You have your output. So this is procedural way of doing things. This is normal programming, right? Then you have your output here. So this is normal programming. But in AI machine learning, you have your input. You have your input. Let me draw a box like this so that you know the difference. Please, in machine learning, you have your input, and then you also have the output as well, what you're expecting, right? In machine learning, you have the input and then the output, what you're expecting, right? And then you have the model in the middle. You teach it, you're teaching it, right? You're teaching the computer, right? You have the model, which is just a mathematical function, right? And then as the output, you have a what? You have a predicted output. You have your prediction, right? It predicts new outputs. New output, right? So you see the difference, right? I hope you guys know the difference now. In normal programming, you have your input, and then you have some certain rules that you have some certain analysis that you're applying on the input, and then maybe you get an output, right? You get your result. But in machine learning, it's different. You show the computer, let me just use computer for the model. You're showing the computer, hey, this is the input and this is the expected output. So I want you to learn this. For every input, this is the expected output, right? And then the computer is going to learn, the model is going to learn the input and the output, so that whenever it sees a new input, it is going to make predictions. It's going to predict the output, right? Whenever you show it an input without an output, it is going to predict the new output for you guys, as simple as that. For example, in the context of data analysis, for example, let's say you gave it your sales data, and then, for example, a real life example that we use machine learning is in data analysis is, for example, predicting maybe salaries from years of experience, right? Or we can use machine learning to classify emails, right? For example, if you go to your Google, now, there's a folder called spam, right? We can use machine learning for spam detection. This is actually a beginner machine learning project that maybe we can do in the future, right? A spam detector. You can show it in an email, and then you can label that email as a spam. So the model is going to learn that, hey, a certain email is a spam, right? And whenever it sees a new email, it can be able to predict whether the email is a spam or not, as simple as that. So that is how Google is automating the spam detection process using this spam detection model, as simple as that. So, and another analogy is, for example, let's say normal coding is like giving instruction, right? Giving instruction to someone. For example, let's say cooking instruction, right? Maybe cooking instruction. And in machine learning, it's like showing the machine learning model, let's say 100 meals, and then it's going to learn how to cook them, as simple as that. But in normal coding, is like giving a chef some cooking instruction. Hey, put this, a little bit of spice, a little bit of, right? And then in machine learning, you show the model maybe 1 million varieties of a meal, and then next time it's going to learn how to cook from those varieties that you gave it, as simple as that. So this is the difference between a normal procedural programming and machine learning, right? So please go back to the chat section. I'm going to be asking you guys some questions, please. Okay, somebody is saying, I tried to load another data in the Matplotlib and Seaborn after practicing with the tip data set, but it could not load. My question is, how can I load other data in Matplotlib and Seaborn and do my data visualization to work with the employee data with issues? Okay, employee data with issues. I don't understand the English. Juliana, what are you trying to say? You try to load data in the Matplotlib and Seaborn after practicing with the tip data. Okay, the tip data that is built into Seaborn, all right, but it could not load. Please, if Seaborn is installed in your machine, there's no way that it's not gonna work. Please go ahead and check the video and check the syntax for importing the tip data set, right? Please go back to the video and please do ensure that you've already installed Seaborn to your machine. Pip install Seaborn, please. Pip install Seaborn. After you do pip install Seaborn, if you're running a Jupyter notebook, go to the code section in the Jupyter notebook cell, run exclamation mark pip install Seaborn, and then try to load the tip data set again, and it's going to work. If you're having difficulty loading the tip data set, please refer back to the video. It's visible, please. It's self-explanatory. It's as simple as that. Please, based on today's class, I want you guys to storm into the comment section, please. Jump into the comment section. What do you think? What's the difference between supervised and unsupervised learning, please? Based on the class we did so far, what is the difference between a supervised learning model and an unsupervised learning model, please? Okay, Juliana, you load a customized data set. Okay, if you Okay, if you were able to load a customized data set, if Seaborn is working successfully, please go back to the video and check, right? Go back to the video and check again, right? How to import the tip data set. Maybe, see, please check your spellings. Maybe you're writing tip or tips. Just check the spelling, please. Go back to the video and look at the spelling. If you miss an S, right? Or if you add an extra space, it's not going to work. Please go back character by character. Try to import the tips data set. I've already done that. That's why I don't have to do it again for you guys. I've already done that. Please go back to the tips, go back to the data visualization video, and then go back to the point where I was installing, I was importing the tip data set, and copy me character to character, please. And it's going to successfully load the data set for you. All right, Engineer Godwin says in supervised, the data is labeled, while for unsupervised, data is not labeled. Wow, that's amazing. Okay, how about semi-supervised? How about semi-supervised? Okay, Prince said in supervised learning is when the model is allowed to learn freely. Unsupervised learning is when the model is allowed to learn freely on the internet. Okay, while supervised learning is when the model is trained with limited and verified information only. Okay, you think. Thank God you said you think. Thank God you said you think. Prince, with supervised learning is when the model is trained with limited and verified information only. See, please make it simple. Implicit is better than explicit, Prince. Supervised learning is when you give the model the data, maybe an item and the name of the item. Unsupervised, item without name. As simple as that, please. When I maybe if I show you, what do I have on my table now? Okay, if I show you my power bank and then I tell you, hey, Prince, look at this one. This is a power bank, right? This is a power bank. And then I show you the power bank. That is called a supervised learning. Firstly, I'm showing you the power bank. And secondly, I'm telling you that, hey, this is called the power bank. And in unsupervised learning, is when I say, hey, Prince, look at this, right? Look at this. And then as a human, your brain is going to try and see and detect and recognize all the patterns on the power bank. Okay, it has a square shape, all right? Okay, this like a USB port on it. This definitely must be, this should be a power bank, right? As a human, that is how we think, right? So that is called an unsupervised learning. Please make it simple, right? Yeah, Paul, you're right. Supervised has labeled data. Very good. Supervised learning, labeled data is given to the model to predict the outcome, while for unsupervised, a large amount of labeled data and unlabeled data is given to the model. The model is able to predict the outcome. Oluwaseun, you're right, but there's a little bit of issue. Unsupervised is when you give a large amount of unlabeled data. You only give some portion of label and some portion of unlabeled data in a semi-supervised learning model. Please take note of that. That is why I'm asking you this question, because there's a contradiction, please, right? There's a contradiction. Unsupervised, you don't give a label. Semi-supervised is when you show the model some data with a label and some data without a label. That is why we call, for example, if a gun is semi-automatic now, right? Sometimes it's automatic, sometimes it's not fully automatic, right? When something is semi-automatic, right? So semi-supervised is plain English, right? It's semi-supervised. Some labeled, some unlabeled. Supervised, all of them are labeled. Unsupervised, there's no any label. Simple as that. Reed says, for the supervised machine learning model, label data is supplied for analysis, for prediction, please, for prediction, while unsupervised data are on label. Yeah, that's great, Reeds. I don't know maybe if that's your nickname or your full name. Lanik Babe, Oluwaseun says, unsupervised, the model is allowed to examine data in order to examine/predict outcome without examples. Yeah, that's correct. unsupervised, say without labels. Please do not say without example. I want you guys to be talking like a data analyst, right? Please use all these keywords, right? Do not say without example, say without labels, please. I don't want a situation whereby as my student and maybe you're discussing with professionals and you'll be saying without examples. No, please use the terminologies, labels, right? Labels, without labels. And do not say examine, please. Say predict or learn. Instead of saying examine, say learn from the data, and then in order to make predictions without any labels, right? So please learn the terminologies. Supervised learning model can be linked to teach machine using sample data and their label for feature recognition, okay, and prediction of same, while unsupervised data with given large clusters of data, and the machine is allowed to learn and label the cluster over time. Well, let me read that again. While unsupervised, the large cluster of data and okay, yeah, please do Ishola do include without labels. So please, if this is an exam, I'm just gonna give you like 6 over 10 because you did not include unlabeled data, please, unlabeled data. Yeah, Prince, you're welcome. Very good. Unsupervised. Yeah, admin is making some clarification. Please just go by. Yeah, you're right. Yeah. Oh, okay. Oluwaseun, thank you so much for that. Semi-supervised is when some are labeled and some are not labeled. Yeah, Abogorin. Semi-supervised. Yeah, you're right. That's correct. Okay. Read, your name is okay. Nebolis Rita Oyenemua. Please correct me if I'm wrong or correct me. I'm trying as much as possible to pronounce your name correctly, please.
So we can't hear you again.
I know, don't worry. Don't worry. I already have an app that is running because whenever there's no audio, it's going to notify me. Don't worry. We're not going to be having that issue again. So Rita, I don't know if I'm pronouncing your name correctly. Is it Nebolis Rita Oyenemua? Please correct me if I'm wrong. So please, do you have any question pertaining to this class? If you have any question, please go ahead and ask. If you don't have any question, please, in our next class, I want you guys to go and further research all these machine learning concepts. If you want the slide, I'm going to be sharing the slide with the host, and then it's going to drop it in the WhatsApp group. So in our next class, please go and read, because in our next class, we're going to be diving into some advanced concepts where we're going to be building some models, right? Because if you take a look at this outline, we're going to be building some regression models, right? That is what we're going to be doing in our next class. So please go and study, right? Okay, Abdul Jamil Surulere said supervised data is labeled, semi-supervised shows the pattern of the particular data, semi-supervised pattern of the particular data. Okay, while unsupervised does not indicate labels. Yeah, unsupervised does not indicate label. You're right. Supervised is labeled. Yeah, semi-supervised shows the pattern of the particular data. I don't know what you mean by pattern of the particular data. Pattern. See, on semi-supervised is some of the, simplify your English, please. Do not complicate things. Semi-supervised, some labeled data, some unlabeled data, as simple as that, right? Simple as that. Let me make it simple for you guys. In semi-supervised, all of you, we all know that we have like 10 varieties of mangoes. We all know that, we all believe that we have we have a green mango, we have a green apple, and we have a red apple, right? Right? So I can show the computer a green apple, right? And then tell you that, hey, this is an apple. So if I show it a red apple without the name, it's going to predict, or it's going to label it as an apple, right? So many unlabeled data, and some like 20% of your data is going to be labeled, while like 80% of your data is going to be unlabeled. As simple as that. That's what we call it's like giving the model a little bit of tip about your data. That's called semi-supervised learning. So please, if you have any question, go ahead and ask. If you don't have any question, we can call it a day. So get ready because we are going to be building some machine learning models in our next class. So please, I want you guys to go back to Pandas and go back to data visualization using Matplotlib and Seaborn. Go back and revise those lessons, because we're going to be using Pandas. So we're going to be using scikit-learn and Matplotlib, right, to build our model and then make some predictions out of our model, right? So Jackson said in supervised learning, the model is given data and a label to predict the outcome. Okay, that's correct. While in unsupervised, the model is not provided with data and labeled data. Yeah, that's correct, please. That's correct. Okay, Ishola. Okay, Prince says he needs access to class 13. Please, admin is going to answer that. Supervised learning model can be said to be teaching the machine using sample data and their label, correct? For feature recognition and predictions, yeah, that's correct. While unsupervised deals with giving large clusters of data without labels, and the machine is allowed to learn and label the cluster over time. Yeah, Ishola, you're right. Ishola, you're right. Ishola, that's very correct. So Prince says he need access to what? Class 10 and class 13. I don't have access to those classes, please. The admin is going to answer that. So please, Justice, I'm going to be handing over the class to you because tomorrow is Monday. I'm resuming work officially tomorrow. So please,